Hello, thank you for joining me. This video is dedicated to the derivation of the quadratic formula. We have a few other videos about the quadratic formula, but this one is only going to deal with how we derive this formula, which I already have up here in view. So the quadratic formula is a formula for finding the solutions of a quadratic equations or the zeros of a quadratic function, which is the same thing. A quadratic function where we would have y or f of x equals this function, and the zeros are where the function equals 0. So this formula gives us two results, because when we have a quadratic equation, we can have two different zeros or two roots or two solutions. And here you see we have a plus and a minus, where one solution is given by taking the plus sign and the other by taking the minus sign. We have a video of how to use the quadratic formula. We have a video that discusses in more detail what's happening inside this square root, which we call the discriminant. But here we will consider ourselves only with how to derive this formula, and it is actually an application of the method for solving equations, which is called the complete the square method. And we do have a video in this same playlist explains this method. So if you haven't had a chance to see the video on completing the square, I suggest that you go there before you review this video, because in this video we will make use of that method, but we won't explain it from scratch. So if you have any trouble with this video, that's where I would go to get a refresh on what the method that involves completing the square. Okay, so what do? We have this equation. I'll write it over. Ax squared plus bx plus c equals 0. And this is a very general form for a quadratic equation. When we complete the square, what we're trying to do is we're trying to write our equation in some form, and I'm going to use like apostrophes here just to show that it's not the same a and b. We want to write it as some kind of square equals some kind of other constant. So we would like to put our equation into this type of form. So how do we do that? Well, we do a few arithmetic tricks here, and there's no reason not to sort of just follow along. Don't feel that you have to remember these tricks. They're just the way we most simply get to a nice complete square form. So the first thing we will do, I'm going to erase this again so that everything is clear, but just remember that that's kind of where we want to get to. Okay, so we have our equation, and the first step I'm going to take is I'm going to multiply both sides of this equation by 4a. Okay, I'm going to multiply both sides of the equation. I can use the equation multiplication property, where if I do something to one side of the equation, I do it to the other as well. When am I not allowed to do this? When a equals 0. But in our case, a does not equal 0. We're definitely looking at a quadratic equation. If a were 0, we would just have the b term here, b times x plus c, and we know how to solve for that. So we're definitely looking at a case where a does not equal 0. So what do we get? Let's write this out. So we have 4a times ax squared plus bx plus c equals 4a times 0. So the right-hand side of this equation is easy. 4a times 0 is 0. What happens on our left side? Let's open these parentheses using the distributive property. So we multiply 4a by each of the items inside the parentheses. So we get 4a times x squared plus 4a times b times x plus 4ac equals 0. Okay, so what do we see here? Our first term here is 4a squared x squared. That is the square of 2ax, right? If I take 2ax and I square it, I'll get 4a squared x squared. So let's write that out here, 2ax squared. Now I'm going to write this as 2 times 2axb. This is our second term. So for some reason I chose to break up the 4 into 2 times 2. I switched the order of the x and the b, and I get this term. What does this term look like? It looks like 2 times 2ax times b, right? And that's what I wanted it to look like. I don't really need to write this twice here. I'll erase this quickly and clean this up. I'll just put these parentheses around 2ax. The parentheses are meaningless because all these operations are the same. They're all multiplication. But what we're getting here is that we have a first term. Then we have 2 times that same term, right? Except here it's in the first term it's squared, and times b. So I'm getting close to a complete square. Remember, complete square, let's look at this up here, equals a squared plus 2ab plus b squared. So this is the form I want to get to. How do I do this here? Well, I still have to get this third term, the b squared here. So I'm going to add b squared, but I'm going to remember to add b squared to the other side as well, right? We have to do the same operation to both sides. And then we mustn't forget the 4ac. Okay, so at this point, we have a complete square here, right? We do have something that looks like a complete square. So what do we do now? Let's write it out. So we have 2ax, that's our first term, plus b squared, right? That is these three terms, plus 4ac equals b squared, right? The 0 plus b squared is just b squared. Now let's subtract 4ac from both sides, and we get 2ax plus b squared equals b squared minus 4ac. Okay, we're almost there. Our next step will be to take a square root of this equation. And again, when we take a square root of one side, we have to take a square root of the second side as well. So when we take the square root of a squared item, so we have square root of 2ax plus b squared, well, obviously, the square root is just the inverse of the square, and so what we'll get here is just 2ax plus b. On the other side, we're looking at the square root of b squared minus 4ac. We're not looking at the square root of b squared minus the square root of 4ac. We have to do the square root on the entire left side here, okay, as one unit. So it's as if we have parentheses on that side and we take the square root of whatever is inside the parentheses. Now there's one thing here that we have to add, and it's really important, and that is that when we take a square root of this side, we can take plus the square root or minus the square root. Why is that? If, for instance, on this side we have the square root of 4, well, the square root of 4 can be 2, but it can also be negative 2, because negative 2 times negative 2 is equal to 4. So it's very important that we remember to take both of these results, meaning we can have a situation where 2axb equals plus the square root, or we can have 2axb equals minus the square root. So where does that lead us? Well, our next step is going to be to subtract b from both sides. Minus b, right? So we have on our left 2ax, and on our right we have minus b plus minus square root of b squared minus 4ac, right? Our final step will be to divide by the coefficient of x. What is the coefficient of x? It's 2a. And now you see why it was important that a is not equal to 0, because we are not allowed to divide by 0, right? Dividing by 0 leads us to an undefined answer. So we know that our a is not equal to 0, so we can divide both sides by 2a. And we get that x equals negative b plus minus square root of b squared minus 4ac divide by 2a. And that is the result we were looking for the formula. So no matter what our quadratic equation is, we can always try and find our two solutions, x1 and x2, by using this formula. X1 will be given by using the plus version, and x2 will be given by using the minus version. The important thing to remember is this will not work with a linear equation, because in that case a will be equal to 0, and we don't want that. And we always look at both results. Now, in a follow-up video, we will discuss in some more detail what happens with this square root. For instance, what happens when 4ac, for instance, is larger than b squared and we have a negative inside the square root. We also have a video that will show you how to basically use this formula in a simple equation so that you can practice it. So if this video was helpful, please press the like button, and please check out the entire playlist for the quadratic equations. It'll offer you a few other methods for solving and just a better understanding of quadratic equations and parabolas. So thanks for joining me, and see you next time.